Today, God willing, we will start the beginning of the closing for the circuit breaker. As we understood yesterday, the connection or loop of the AC and DC operates in the station. Now we want to see together regarding the loop specific to the closing circuit. All right, and let's see how it is formed, or how its circuit operates step by step. So here, yesterday we talked about F51, which is specific to it, and today, God willing, we will start with it, and we will find that it is this one. The first circuit I have is the one circuit breaker, close and conductor circuit, circuit breaker, close and conductor circuit. All right, guys, the idea now is that we will start with the positive and negative, as we agreed, coming from the DC board or the DC panel that I have in the building, whether it's 115 kV or 132, whatever the high voltage you're working with at your station, wherever you are in any country. So here you have the positive and you have the negative. I will focus on the loop that is running here, going back and forth or coming and going directly on F31. I won't talk about F32 right now. That's related to the trip circuit. After we finish the closing circuit, God willing, we will move on to the tripping circuit. Great, okay, now I have taken the positive and the negative. I first connected them to the MCB as we agreed. Of course, the positive and negative are coming from an external circuit. How did you know, it's from an external circuit? You knew from the end of something remote. We knew through the fact that this is the box with the dashed line, and inside this dashed line is another box that is half black and the other half white. So this means that it is remote or SCADA. The term remote is used because, firstly, it is not coming from any mechanism box present in the GIS, nor from another LCC panel, nor even from anything inside the GIS or LCC. So it is from something else, which we refer to as the remote panel, which is the DCDP. All right, it entered through the MCB. Here the negative goes directly without any issue. However, for the positive, as you can see, it takes a branch here, which we call direct positive or direct DC. And I have another branch for the positive, which is interrupted by something called S11. All right, so what is S11? S11 is a selector switch. Selector of what? A selector switch. All right, so S11 is the selector switch drawn in front of us, and it has several positions. As you can see, it indicates that there is a branch here, or a branch here, which is emergency. There is another branch next to it, which is local. And a final branch, which is what? The remote. So you have emergency, local, and what? Remote. Nice, great. So you find in this line a direct positive. You took a part of it directly, and the other part you split into 3 parts using a selector switch. This selector switch allows you to choose from either the emergency position, the local position, or what? The remote position. If you choose the emergency position, the contact at numbers 25 and 26 will close. If you choose the local position, 27 and 28 will close, and the other two, 29 and 30, will close if you choose the remote position, and the rest will remain open. Anyway, engineers, you will find on the same page regarding the selector switch, and this is also what we have seen, thank God. What we saw on the previous page, where it listed the switch named S, and I told you that I will explain it to you in more detail later, God willing. Here, it always draws its diagram for you, saying, here you have switch S11, which is located above. This switch has 4 positions. Off, emergency, local, remote. Exactly. Off, emergency, local, and remote. And what is this, guys? As I told you, it's a selector switch with 4 positions, either off, emergency, local, or remote. As you can see, it lists the contact terminals for you. 1 and 2 are one contact. 3 and 4 are another contact. 5 and 6 are a contact. 7 and 8 are a contact, and so on. 2 is a contact. 3 and 4 is a contact. 5 and 6 is a contact. 7 and 8 is a contact, and so on and so forth. All right, great. And then it starts to mitigate your betrayal or the basket you have that moves with a certain balance. What does that mean? It means you have contacts number 1, 2, 9, 10, 17, and 18. These 3 only close if you have your switch set to the position. Set to emergency, 43 changes with 11, 12, 17, 20, 25, 26, 31, 32, 37, 38, 44, 45, 46, 47, 48. 20, 26, 31, 32, 37, 38, 43, 44, 45, 46, 47, 8, and 4. So you have the chart that I'm drawing for you, which means it tells you that each contact in the selector switch changes its position at exactly which position of the selector switch. Nice? Good. And finally, the last column here tells you which page each of these contacts is used on. All right, so here we have the contact numbers. As you can see, 25, 26, 27, 28, 29, 30. If we look at them down here, if we look at 25, here is 25, 26, 27, 28, 29, 30. As you can see, this works with the emergency, local, remote compensation, because we already know that they are 4 slots: off, emergency, local, remote. So here you have emergency, local, remote. When you set it to the emergency position only, this is the level, and the rest are all open. When you set it to the lock position, it closes, and the rest are all open. Or let's say the rest are in their normal position, exactly, and so on. Now, I have a bit of confusion here. What is the normal position for the switch supposed to be? What does the normal position mean for the switch? Is it emergency, local, remote, or off? What is the normal position for your selector switch? So you have your selector switch as drawn in your diagram. In what position? In the off position, exactly. So for you here, as you can see, it is neither emergency, local, nor remote. When you set it to the emergency position, it closes. And the other two will remain open. If you set it to the remote position, the local will find 25 and 26 open, and 27 and 28 will close, while 29 and 30 remain open, and so on. So where did all this information go? All this information went to page 10P1 and 10F1, where the positions are indicated as negative. Now, if you come to page 10, here it is. This is page 10 for me. All right, and this is the closed control circuit for the circuit breaker, number 601 Washington. All right, my dear. So if you come here, engineer, you told me 10P1. All right, here are the 4 terminals that were coming. Here is P, and here is 1. So this is the intersection B1. Here are my 4 terminals with me, which are the emergency, local, and remote branches. And you had 1 direct positive, which tells you what, right? And here is the negative, located at the very bottom, which is where? In 10F1, page 10 that we are on, and here is F, which is the row, and 1, which is my column. All right, great. So this is my negative. Okay, you have the negative present in the entire circuit. Only the positive is supposed to be there, right? Let's take it easy so we can dissect this circuit easily. The idea is quite simple. Here you have the closing or the closing circuit specific to the circuit breaker. This page is talking about the control circuit specific to the closing of the circuit breaker. You have Y1, which is the closing coil. This is the closing coil. And for this closing coil to work or receive a command, the contactor or auxiliary, which is called K11, must operate. Very well. So when the contactor or auxiliary K11 operates, its contactor closes, which in turn closes the circuit. So where is K11? If you look below, it tells you on page 10 F1. I am on page 10. Where is F1? It will come like this. Here is fifth. And here is 1, which is the first column. I will go down here and I will find K11. So now my main concern and all my thinking is about how K11 will operate, because when it operates, what will it do? As soon as this coil, since I mentioned it needs to operate, I am talking about a coil. As soon as the supply reaches this coil, all it will do is close what? It will close the contact here. That's a question we haven't forgotten. All right, so what will happen is that when K11's coil operates, it will close its contact here and start to supply DC to the closed coil to close the circuit breaker. So now let's think together about how we can operate the contactor named what? Named K11. Sounds good? Great. Let's see together how we will operate the contactor named K11.